student to read for us. I think right above there, I think I listed the steps that they wish we would follow in trying to sketch one of these polynomial functions. Who would like to read? Yes.
You want me to read all of them?
Read number 1 first. Let's see what it says.
Analyzing the graph of a polynomial function, number 1, determine the end behavior of the graph.
Oh, they want us to get that end behavior done right quickly. You guys, hang on now, number 1. Of course, I get the long black marker. They want this. They want to know what's going on the ends. The ends here, your behavior. Whoa! Now they're a clever student to tell me what might you do to try to determine what is my graph going to do on the end. On this one, on this end, it was increasing forever. On this end, it was dropping down forever. That was the end behavior. Is this one going to be doing the same thing? Now, who has a clever idea of what should I look at up here to determine what is my graph doing on the ends, and then I'll draw the sketch or draw a grid, and I'll go to the ends and do that. Yes, sir.
I noticed the degree would be x to the 4th.
Whoa, hold on. Whoa. You're saying without completely multiplying all this mess out, which I would not ask you ever to do. The students tell me, is the degree, when I add up all those exponents, is the total degree 4? So I'm looking at a graph of, I'm in my mind thinking, well, whatever an x to the 4th graph looks like on its ends, mine must be doing the same thing. Right? Over here was an x cubed. So let's go right now with that help and try to put some pieces together here. All right, guys, my zeros are easily seen. If you split these up, I see a -1. Help me out here, please. -1 here. I see a 1. And I guess I see a 2. So I'm going to mark those. These are my zeros, x-intercepts. Step back and look at that, make sure we're okay. Does anyone recall what? On the side here, a simple x to the 4th graph looks like. Just a basic one, because this one should resemble it on the ends. Does anyone think they know? And I'll just make a quick sketch. Or something like a parabola somewhat. Maybe not quite, but you're saying maybe. What's the other word here? It may look something like this. Is that true? I mean, just for the ends. I'm more concerned about the ends than anything else. Does an x to the 4th graph, do you think, looks something like that on the ends? If so, this graph should be doing the same thing. That means if I go to this end, right here, this end, my graph should, hang on, should be doing something like that. By the way, is this copied down correctly? Everything done correctly so far, guys? Okay. So are we saying this should be doing something like that? And on this end, something like that, as this one is doing on the ends. Yes or no? I gotta get an agreement, do we?
No,
On the ends.
because it's multiplied by -1/2,
Beautiful.
so it'll go down.
Beautiful. Was there a -1/2 in front? So that term there, I see x to the 4th. Just wait, Professor, you better remember, look at this carefully. There was a -1/2 there. That's the reason I did it. What might that -1/2 or that negative sign do to my x to the 4th graph? Is it now doing this business? Therefore, my graph should be doing the same thing, except, here we go. it's now something like this, doing this. Would you guys agree at this point on the ends? Does it do something like this? Woo! Now that's done. I don't have the graph. Now let's go from left to right. I'm at -1. Well, -1 came from this factor right here. I'm gonna pay attention to or notice to the exponent involved on each one of those factors. Guys got an exponent of 1 here. I got an exponent of 2 here, and an exponent of 1 here. They tell me something about the graph. Now, who was reading for me? Was someone reading for me? Yeah, would you read step 2?
Step 2, find the x and y intercepts.
Yeah, why not now? I got the x-intercepts already, they're called 0, they were done. Y-intercepts, in case I need it, let's find p of 0. Guys, if I replace all these x's by 0 and I'm careful, I think we're end up with a 1, looks like a -2, yes or no? Is that altogether a positive 1? I'm up here. That's my y-intercept. So I've got the end behavior, I have the x-intercepts, which are my zeros, I had those already. Now I got the y-intercept. Read number 3 for me.
Determine the zeros and their multiplicity. Use this information to determine whether the graph crosses or touches the x-axis.
Oh,
X-intercept.
got you. Now they want you to list each one of those zeros, x-intercept, and based on something that's going on here, are they representing multiple answers? I've got zeros of -1, +1, +2. Those are my zeros. Does anyone think they know what on earth is this telling me or asking me to do? At -1, 1, and 2 for those zeros. He's talking about something, what, multiplicity I think it was? Yeah, multiple answers. Does anyone think they know at -1, is that to be represented as a multiple answer? Does it show up twice? Is 1, the other 0 over here, is that a multiple? Does it show up more than one time? In some essence here, and 2. Does anyone have an idea? And I'll explain to you, it's gonna be very, very easy for us. Go for it.
One as an answer
Okay, if I have a 1 outside here and I solve x plus 1 and get that -1, does that 1 right there tell me it just shows up one time? And by the way, is that 1 on the outside even better? Is that an odd number? Of even odd numbers. If I move here, I do get 1. If I solve this, x minus 1 squared, set the x minus 1 equals 0, get it? But with that squared, does it really mean 2, 2? You actually have 2 answers. And is that outside exponent there an even number? And the last one, another odd number, and it shows up only once. So I'm looking at even odd. So if I have this one to be an odd number on the outside, which it is, that means it's going to do what at -1? It's going to cross. So if it's an odd number, it's going to cross the axis and go up, and it may go up directly to that y-intercept, it may not, it may, let me make this graph a little better here. Let's see if it looks something like this. It may go up and then come back down, but it's got to finally pick up that y-intercept. Now, I gotta finish the graph up. Now it's coming down, it's gonna pick up 1. Now when I hit 1, which came from this factor, the exponent on the outside was what? Even. What do you think happens to even? It does not cross, it bounces back. It's gonna bounce back. How far up it goes, I don't know, you don't know right now. It may go way up there, I don't know. But it's gotta come back and finally pick up my last 0. Let me make this look a little better here. It drops down. There's your graph. We're looking at the odd even. If it's odd, it's going to cross. at that particular zero. If it's even, it's gonna touch and bounce back at that particular zero. That's a great benefit in graphing these. So we got the end behavior, we got the zeros, we got the cross touch. Was there anything else?
Yeah, it says determine the maximum number of turning points on the graph.
Now, did I give a little formula on the end there on how to find that or not? I didn't specify how to find it. Okay, guys, first let's count the number of turning points. Now, they're asking if this is the correct graph. At this point right here, somewhere here is a local maximum value. So that's one turning point. Here, another turning point. And here, another turning point. So guys, I have what? 2 local max and 1 local min. 2 local max and 1 local min. Woo, at this point. All together, how many do I have? 3. 2 local max and 1 local min. What was my degree in this polynomial function? The very first term was, I think, what was it, -1/2? I think someone gave me x to the 4th. Is this the way the first term looks? On this one? Right here, did I erase it here somewhere? Right here. Is my first term -1/2 x to the 4th if I should expand that thing out over there? Is it? -1/2 x to the 4th? Okay. Now, my degree is 4. The highest exponent is 4. How many turning points did I have in this case? No, I didn't have 4. How many turning points? I have 1 here. Looks like we have a local max somewhere in there. I've got 1 here, that's a min, local min. And I have 1 here, another local max. 1, 2, 3, do I have 3 of those extreme points? In this case, 2 local max and 1 local min, yes or no? Now the rule is, usually, not always, the rule is usually you take this degree, the highest exponent, and subtract 1 from it. And that may tell you how many of these to expect. So 4 subtract 1, they call it n minus 1, gives me 3, so expect 3 extreme points. In my case, 2 local max and 1 local min. And what's the next part?
Sketch the graph, additional points may be used to refine the graph.
Okay, additional points. And guys, I did not plot any additional points. Who knows? Things can go crazy on us. I had my point here, who knows? It may have been way up here. I didn't plot a point. I didn't use a table. Or this point here could have been way up here. Who knows? I wanted a shape of this polynomial function. And that's the shape. That's done. Done. Let's see by a show of hands real quickly. How many students have actually heard somewhere about what those odd or even exponents tell you about the graph? I see 1 student. I see 2, 3, maybe 3 students. What a big benefit. If it's odd, it does this. If it's even, it does this. Cross or touch. Okay, guys. Mr. Park, you have a graphing device of any sort with you?
Yeah.
Graph that for us, and I know I did not plot additional points to get a really good graph. But go ahead and do it. And see if it's close to, anywhere close to what you see on the board. We'll see what happens. I will just see if it looks something like it. Sure. Oh, you got it? Oh, you can't use this on a quiz or a test. Oh, yeah, I want you to practice for me, see what it looks like.
I'm sorry. It takes a while.
That's okay.
Yeah, it looks similar.
It does?
Yeah, but.
Now, let me ask you, it looks, the shape at least looks similar, right?
Uh-huh.
Did maybe this point here go up higher or something like that, or what?
So the local max, it's at the left side of the.
On the left side here?
axis, yeah.
It's up here,
Yeah.
it's higher. And how about this one? There's
It's
another
more
one.
lower.
Is it lower really?
Yeah.
Lower than what I have.
Mm-hmm.
Okay, but the shape looks pretty good.
Mm-hmm.
That's what I'm concerned about, the shape. Okay? So the graph looks something like that. Any concerns there, guys? Wait, too easy. I think there was another one there. Was that letter C I just chose there? Was it letter C or did I see letter two? Number two is one idea. We should try number three before I leave it. It's the sketching done. Number three, just to make sure. She hasn't close by. Tell me what that last one there, two or three of them was. What was the function?
P of x is equal to negative x cubed, parentheses, x plus 5 to the fourth,
Oh, okay.
parentheses, x minus 4.
X minus
4.
4. Wow. Oh, Lord. They want to schedule this. June and Mr. Park, they can tell you that you're gonna see these sketches, but you will use a little calculus to help you with the sketches here. June, Mr. Park, they also mentioned probably math 7, something about concavity, concave up, concave down. I don't think the textbook here does say much about concavity, if anything. Guys, this one, anyone tell me what the first term looks like, the very first term? If you should expand this out, don't fully expand this. What would be, now I erased it, what they call A subscript N. The first term out front looks like what?
8.
Square the negative. X to the, I heard it,
8.
8. That's what the first term, if you should expand that full thing out, you would get. I don't know if I should multiply all that mess out, just look for that first term that's going up. Just out of curiosity, does anyone think they see what the constant term would be on the end? Without multiplying all this out. Oh, that's a big number. Wow. In other words, what is it? You want to have an idea what would end up on the end if you should fully expand this mess out? I think it's 5 to the 4th maybe times -4. Is that true? It would be some big number. I'm concerned about that first term. So I'm concerned about. I'm about to multiply this out. Now, can anyone tell me before I get to the grid and start graphing? We'll graph this fairly fast. Does anyone have an idea what this graph, almost like a paragraph, what this graph looks like as a basic shape? Because my graph is supposed to, out on the ends, behave just like it. Does anyone have an idea what negative x to the 8th, just that basic graph, might look like?
Parallel,
And, some more.
looking down.
Okay, like this, something like this.
With 8
That's right.
points between.
Oh, by the way, did my last one sort of do the same thing?
Thank you.
Yes, yes.
Was x to the 4th over there? No, this is x to the 8th, was it the same thing?
Yes.
Okay, so that tells me the end behavior, right now I know the end behavior. Based on this, let's get that end behavior out of the way, then I'll take questions here. The end behavior. I'll write this out so we can see what it is, guys. I'm gonna use my limit notation, limit, as x is approaching, let's start on the left, negative infinity of my function based on the red graph. Should be doing the same thing on the left. My graph should be doing the same thing on the left as the red graph is doing on the left. Guys, as I walk this, negative infinity says you're walking this way forever. You're going that way. Like that.
Yes.
What's my red graph doing as you drag it along with you?
Also
Is it dropping down forever? Described as On the other end, let's use the word, or the abbreviation limit, or limit. As x is approaching positive infinity, now I'm going out this way on the x-axis forever, and that red graph is being pulled along with you. What's it doing out there, the red graph? Is it also dropping down forever again? That's called end behavior. Okay, we got the end behavior out of the way. We'll do something like this last prep I did here. Number 2, let me pick up the zeros right quickly. All right, the last one I get to sketch today. Zeros, now help me out, guys. To find the zeros, you know it merely says set each one of these factors equal to 0 and solve. So I see right now, if I said this equals 0 and doing my business, there's 0. This one's going to give me what? -5? And this one's going to give me a 4. So we'll write this guy as 0, -5, 4. Now, I'm going to start using the word multiplicity. Multiple. There's multiple responses here. 0 came from this factor. On the outside, I see a cube. What might that tell you about this 0 in terms of being a 0? What's that 3 tell you think?
That it crosses.
And thank you, it's going to cross when I get to the grid. Absolutely, it's going to cross because it's odd. Here's an odd number, so it's odd, it's going to cross. As we just described over there. Tell me something else about that. 0 is 0, and it came from this factor. What does that tell you about 0?
Is the same as a pen bro?
Getting close. Could I say, I'm not going to ask you to do this though, could I say 0, based on what we did, is supposed to show up 3 times? We just listed once, but it's supposed to be really 3 times. -5 came from this factor. Now see on the outside, what, is a 4? So that really tells me what? -5 is acting as a 0 what? 4 times? That's what's telling me. We just was -5 once though. And 4, of course, came from this one, which looks like on the outside is understood to be a 1, and therefore this says what? 4 just shows up what? Once. Now, that's where they start using this word multiplicity. So guys, on the side here, we're going to put yes, 0 is an answer, a 0. But the multiplicity is I like to use this word. I'll abbreviate it shortly. Multiplicity of 3. Shows it 3 times. That's what it means. This one down here, -5, since it came from this factor with the 4, shows it 4 times. Yeah, it is -5. That's -5. Like this. A multiplicity of 4. Let me just abbreviate these. That. And finally, we got 4. And your textbook says it's a multiplicity of 1. It shows up once. That's what they mean by multiplicity. Are there some multiple answers? Okay? So if I add those up, I think I ended up with 3 plus 4 is 7 plus 1, what, 8? And I think if I go through and look at these exponents and then add all those up, is that 8? So I do have 8 zeros to work with. Woo! Now I'd like to sketch it. This will be my last sketch. Guys, got end behavior 0. Oh my goodness, I heard cross touch. Let's get that out of the way right now. Guys, on the first one, it's a multiplicity of 3. Since 3 is odd, it's going to cross the x-axis. Now the next one, I see -5 has a multiplicity of 4. 4 is even. It's going to touch. I see 4, multiplicity of 1, 1's an odd number, we'll cross again. These classes are way too short for a winter class. Way short? Ooh, what's your response? That's way too short. We should be doing at least 5:30. Every day. Okay, maybe take another 15-minute break in between. So far, so good? Okay, so I know where it crosses, where it touches, I know the zeros, I know the end behavior. I think I'm ready to sketch it, aren't I? Do I have everything I need? See what the sketch looks like. Oh, by the way, I got the x-intercepts, those are the zeros. I got those. These are gonna be my x-intercept. Y-intercept is the y-intercept, I'm going to replace all the x's by 0. And I'm gonna get a 0. So the y-intercept. Okay, so I've got an x-intercept of 0, y-intercept of 0. Let's see what this sketch looks like. Done some good work today. Here we go. You guys just place those zeros first. And we got 0, -5, and 4. Okay, -5. It's right there. 0 right here. And it looks like 4. In behavior, I think we described it as this. Throwing this on the ends, which is what my last graph was doing. So let's say, well, Professor, it's got to be doing something like this. Or something like this. On the ends. Now let's get the cross touch out of the way. From left to right. At -5, we decided it's going to what? Touch. Now that means what though? At -5 touches, that means it's going to bounce back, not cross over. So it's going to bounce. And how far down it goes, I don't know. Mr. Park, please sketch this for me. It's got to come back up eventually and pick up that. Now I'm at 0. Guys, at 0, I think we had a multiplicity of 3, so let's cross. So at 0, it's going to cross, make something like this. I don't know how high up it's going to go. It's got to come back and connect with that 4. And I think when I check out the 4, we determined it's going to cross again. Is that reasonable? As the graph of this crazy black function. That's its picture. Mr. Park, how close are we?
It looks almost same, it's just
Oh,
more
we're good.
rapid.
We're good. But the shape looks pretty good.
Mhm.
Thank you. The number of turning points, Andrew, somewhere, oh, I see right here, that's a max. That's the highest point of all points near it. Okay, that's a local max. In fact, it has a value of 0. I see that local max has a value of 0. This one down here is a local min. I have no idea what it is until calculus. I have another local max in here somewhere. I have no idea what the value would be. So guys, I got a local max, a local min, a local max. I got 3 altogether. The degree back there was what, 4? I think it was 4, wasn't it? Right, was it 4 on this? No, it's what,
No,
8? 8. Last one was
That's
4.
4.5.
The rule says subtract 1, why doesn't that leave me, what, 7? So what they say is at most, you would have n minus 1. Okay, so at most I could have 7. I didn't get 7 here. Okay, so that's where they clarify that. Go and use that formula, n minus 1, get an idea. How many turning points should I have? 8 subtract 1 says 7. Professor, that thing has does not have 7 turning points. It has only, if we did it correctly, what, 3? Okay, but the rule says at most you can have 7. Okay. Take a close look at it. Any concerns? Could we graph one of these? I see a hand going up, yes.
So I have a question, whenever we're being tested on this, like, what do we have to show in terms of showing?
Everything on that handout, step 1 will be found in behavior.
But like, for example, when you draw the almost like parent graph, do we have to show that too?
Oh, you mean this right here?
Yeah.
No, if you recognize that.
Okay.
I don't need to see this drawing. That's just for instruction. Anything else? No, I'll have it typed up when I give you a quiz or on the exam. Step 1, find the zeros. Step 2, list their multiplicities. Step 3, tell me where it touches, where it crosses. In behavior, sketch it. Guys, Mr. Park, please tell me again. This looks pretty good, huh? Okay, we're good. You did on a graphing device. You just did roughly. Yeah.
Can you take a winner, example for these or
I will. Oh, whoa. It's not that time, is it? Are you kidding? Someone messed with the clock. Someone messed with that clock in the world. Oh, gee. I want to go longer today. I wouldn't have the exams returned to you, do I?
No.
Oh. Okay, quiz number what, 3?
Yes.
Tomorrow, 10 1. Okay, here we go. Last reminder, Gia. You want to complete the square. I got, start class out with, I'll give you a function, the quadratic. Just throw one together. And it may be something simple like this, maybe a negative out front, it's a negative. I just make up something real quick, guys. Then you gotta go through with it. Process of completion of squared, I know it's tedious, but you gotta go through it, like I did at the beginning of class, put it in that, vertex form. We're in that form, now I can name the vertex, find the x-intercept, find the y-intercept, and sketch it. Okay? That's what I'm looking for. I may have a few more items on there, but basically, a quadratic, you can do the square, put it in vertex form, and then sketch it. Okay? Wow. Should see it. And by the way, I'll be here at 11:30 tomorrow. Now,